guys, today we are describing a project. The name of the project is Driving System for Disabled, and the need to help the person with disability has led to the development of assistive technology. And the technology presented here is designed to help the disabled person. The disabled person with having some sort of trauma or accident cannot move their upper body and lower body. So we have taken an organ from the human body, that is tongue. The tongue is the only organ of the human body that has direct connection with the brain through the hypoglossal nerve, and with this direct connection the brain provides access to the tongue to drive the person in their own way. And in this project we are using the main source of driving is this magnet. When this magnet is placed on the tongue of the person, then the person can move his tongue in any direction, and the magnet produces a magnetic field, and this magnetic field is then sensed by this headset. This headset is designed and it consists of 4 ratiometric bipolar linear Hall effect sensors. As you can see over there that there are 4 Hall effect sensors. The name of the sensor is A1321, and these sensors are designed by the Semiconductor Technologies. These sensors take the value of the magnetic field, and as we have noted the readings from our experiments, that this provides a value of 5 volts when the magnet is placed at the center. And in this demonstration I am just showing that when the magnet comes in close contact, then how the value changes, and the value goes to 2.52, and this 2.52 value is in the analog form. It needs to be converted to digital form for the circuitry to work. Corresponding to this value we have taken the microcontroller, and the microcontroller is MSP430G2553. This microcontroller is designed by the Texas Instruments, and it provides a way to hold the circuit. And here we have got the voltage regulators, that is LM7805 and TLB2217. These regulators are used to drive the circuitry, and MSP works on the value of 3.3 volts. The MSP works on the value of 3.3 volts, and the values from the sensor is taken to the MSP. The MSP has got an inbuilt analog to digital converter. The values are input from this sensor to these input pins, and from these output pins the output that is already converted to digital form is then transferred to this circuitry. Here we are having a wireless circuitry. The circuitry for wireless transmission, the IC used is HT12E. You can see over here, and this is manufactured by Haltech. Haltech Technologies produce this, and here we are having the encoder module. This encoder module works on the frequencies of 315 MHz and 434 MHz. From this wireless technology, the data is being transmitted in this project. This is the encoder circuit. From there the data goes to the decoder circuit. This decoder circuit is designed by Haltech, and the decoder IC uses HT12D. This decoder circuit is also having a decoder module that is 8 pin, whereas the encoder module was of 4 bits. So from here decoder IC, we are going to drive a vehicle or a PWM controlled wheelchair, and here we have designed a prototype, and in this prototype we are just taking this model, a small model that is containing these DC motors. And yes, the circuitry is quite complex, as you all know. Here we are having the voltage regulators. The voltage regulators, that is 7805, LM7805 and TLB2217. You can see over there. You can see from this side now. Hope it's visible. Here we are having the driving circuit by L293D, and the MSP430 is the microcontroller used here. The code burned in the MSP430 microcontroller is in interrupt based, and MSP430 is used in the up mode. The up mode is set to take the interrupt. Whenever the interrupt is generated, the values from Hall effect sensors are being continuously taken, and these values are continuously transmitted over to the driving cycle. The driving vehicle is moved by using this luminous battery that is operating over 12 volts and 7.2 ampere rating. This circuit is for the disabled person. Next, we have also designed some new technologies. This is using the wireless transmission again, and the wireless transmission is being conducted by the LMX. The LMX 9838 is a serial port Bluetooth IC that is also again designed by Texas Instruments. As you can have a close view over here, this is the IC. This is the IC. It is a 40-pin IC, and in this IC there are certain pins that are connected to the ground, that are connected to power supply, and the most importantly 12th pin, 13th pin, 14th pin and 15th pin. These are the most important part of this circuit, and these are the RxD and TxD, as well as your RTS and CTS, that is clear to send, request to send, as well as the received and the transmitted part. This is the circuit that is connected. Here we are having the power supply part, and it is operating over 9 volts, and the circuit when connected to MSP430. Here we are having a launch pad of MSP430. This launch pad of MSP430 provides a base and a way to work on our circuits and get all the knowledge, get all the learning knowledge about microcontrollers, design new technologies, and develop new methods, new products and new prototypes. So with the use of this LMX technology, one can operate the vehicle. The person who are having some sort of hand movement can control this circuitry by using this wireless module placed with this driving circuit. And then we are having Android apps. There are Android apps that can be used to move the vehicles. The next will be discussed in the later parts of the video. Please keep in close contact with the videos. Thank you so much.